Hi, this is Sung. I'm the Principal and Director of Sky Academy, and we've been looking at sequences and series, and we've looked basically at all the theory pretty much now, and we've started to touch on some of the application type questions or the application type problems that you might see for series applications, right? Now, in this episode, what I want to do is look at application type questions for geometric progression. So in the last episode, we looked at arithmetic progression. In this episode, I want to look specifically at geometric progression, and there will be quite a fair few application type problems for geometric progression, all right? Particularly as we move towards kind of like finance and how money works. We will look at things like compound interest, annuities, time payments, etc., which is kind of like a whole nother field or a subfield within sequences and series. But generally, I want to look now pretty much at the general type of geometric progression or geometric series type word problems that you might get. And I've got two up on the board. They're fairly simple, all right, if you know what you're doing, all right. But I do want to go through with them just so that you know, or just so that you can recognize that they are GP number one, but also how to approach them, okay, if you do get a question like this. So let's start with question number one. So you've got the population of a certain town is 10,000. If its population will decrease each year by 10% of its population in the preceding year, so in other words, basically what it's saying is it's decreasing by 10% each year, which tells you what, right? It tells you that the common ratio is, well, not 10%, it's actually going to be 90%, right? Because by taking 10% off, you're left with 90%, yes? So your common ratio is going to be 90%, all right? And it says find the population in 5 years' time. So in other words, what we want is T5. We want the fifth year, or we want the population in the fifth year, all right? Or at the end of the fifth year, which is T5, yes? All right. So what we're doing is we're starting off, so this question is a GP question where, all right, A, in other words, your first term is going to be 10,000. Got it? All right, because you're starting off with 10,000 people. Your common ratio, right? Your common ratio is going to be, right, 90%, 0.9, which comes from, all right, 100% minus 10%. All right, so that's your common ratio, and the number of years is going to be 5 because we want after 5 years' time. All right. And what we've got to try and find is the population in the fifth year, which is going to be Tn, right, or T5, right, is going to be equal to what? Okay, that's what we've got to find. We've got to find T5, right? Now, we also know that for the nth term of a geometric progression, right, the formula for that is going to be A outside of 8 times r to the power of n minus 1. Yes? All right. So let's work that out over here. I'm going to put a little box around that. I'm going to kind of move up over here, and we're going to start the rest of the question over here. What we're looking for is T5. T5 is going to be equal to, and what are we looking for? Sorry, I don't know why I did that line. Let's undo that line. T5 is going to be equal to 10,000 times R, which is 0.9, to the power of n minus 1, which is to the power of 5 minus 1, which is 4. All right. We worked that out on your calculator. So let me just grab a calculator now. I've got one over here. So let's have a look. And I get that our population is going to be 6,561 people, right? So just to finish off, our population in year 5 will be 6,561. Does that make sense? Okay, beautiful. So that's that question done. All right, let's look at the next question, which is probably a little bit, I don't know, a little bit more theoretical. It's kind of probably not as practical as the one before, like in terms of applying it to real life. But yeah, so it's kind of has a little, it's kind of more kind of rooted in the maths world and has less application. But nonetheless, it's a good question for us to do. So you've got 2k plus 2, you've got 5k plus 1, and you've got 10k plus 2, and they are 3 consecutive terms of a geometric progression. Find the values of k, right? So the best way to do this is to use, all right, the geometric test, right? So remember how I went through the geometric tests, and basically the geometric test, test for GP or geometric progression is Tn plus 1 over Tn is equal to Tn over Tn minus 1. Does that make sense? All right. Now, let's work it out. Tn minus 1 equals to 2k plus 2. Tn equals to 5k plus 1. And Tn plus 1 is equal to 10k plus 2. So in other words, what we're saying is this term over this term is equal to this term over this term, or the other way around. You can have it the other way around. This term over this term is equal to this term over this term. Yep. All right. And it'll also work flipped upside down as well. You can flip it that way, you can flip it that way. Okay, I want you to notice that there's a symmetry there. All right. Okay, cool. So let's apply this, right? So what we've got here is 10k plus 2 all over 5k plus 1 is equal to 5k plus 1 all over 2k plus 2, all right? Now, from here, we can pretty much cross multiply, all right? So what we have here is 10k plus 2 outside of 2k plus 2 is equal to 5k plus 1 all squared, all right? And now, from here, it's just a matter of working out the algebra. Let's just do that. So what we have here is 20k squared plus 4k plus 20k plus 4 is equal to 25k squared plus 10k plus 1. All right, so let's bring everything here over to the other side. So what we're left with is 0 is equal to 25k squared plus 10k plus 1 minus 20k squared minus 24k minus 4, right? Which is equal to 5k squared minus 14k minus 3. I think that's what it is, right? Now, we can use the product sum method or we can use the cross method. I'm really familiar with the cross method, right? The cross method is the one that I kind of grew up using, so I'm just going to use that. If you've got another method of doing these sort of questions, please by all means don't let me stop you from doing that, and don't let my method of doing these sort of quadratic equations confuse you either, okay? But I'm just going to do this one quickly. The cross method works really nicely for this one. So you got 0 is equal to 5k plus 1, k minus 3. So k is going to be, well, let me do it. I could probably just go straight to the answer, but let me just do it properly for you. 5k plus 1 equals to 0, or k minus 3 equals to 0, k is equal to 3, 5k is equal to minus 1, k is equal to minus 1/5. All right, so your two answers for k are going to be minus 1/5 or 3, and that will give us a geometric progression for the above terms. Okay, good. All right, so there are two questions. There are two questions on geometric progression, right? Last episode, I basically did some questions on arithmetic progression, right? We are now going to move on to other applications of geometric progression, which are more specifically defined by the scope and the curriculum of the HSC course, all right? Which includes kind of, like I said before, compound interest, time payments, recurring decimals, annuities, yeah? And I just basically said that in a weird order, but basically that's what it's going to be. All right, so thank you very much for watching. I'll catch you on the next episode. Bye.